Let's start our next section, 2.3, which is about evaluating limits analytically. So one thing we learned in the last section is we learned that the limit as x approaches some number, I'm going to call it c, does not depend on evaluating my function at c. So what's happening at x equals c doesn't impact the limit. But sometimes these two things are equal. But we saw that sometimes the limit is equal to f of c. And so in these special cases, what we could do is we could just substitute into the function. So to evaluate the limit by direct substitution. So what I'm saying here, sometimes it's the case that when I take this limit, it's the same thing as plugging in c into my function. So in this section, we're going to talk more about when those sometimes occur. So let's start with some basic limits. Basic limits. So the limit as x goes to c of a constant function would just be itself. And if I'm taking the limit of just the function x, I can just plug in c for that. Also, if I'm taking a limit of x to a power, x to the n, it's just going to be c to the n. I can just plug in, replace x by c in these special cases. So let's look at some concrete examples. If I take the limit as x goes to 2 of 3, this limit would be 3. This is a constant function, so its limit is always 3. If I look at the limit as x goes to negative 4 of x, just plug in negative 4 in place of x, and this limit would be negative 4. And finally, if I look at the limit as x goes to 2 of x squared, this would be 2 squared. Just plug in 2 in place, plug in your 2 here in place of x to get the limit. All right, so the next thing we're going to do is we're going to talk about some properties of limits. So your book has a really nice boxed in list of properties, and I'm going to try to write them all here so we can see them. So supposing that if the limit of f of x as x goes to c is L, and the limit as x goes to c of g of x is k, then we have the following properties. So the first one is if I take the limit of b of a scalar multiple b, so I guess I should say b is just a scalar, I can essentially pull the scalar out. So this limit would be b times the limit of f of x, which we know to be L. The second rule has to do with sums and differences. So if I take the limit of f of x, either plus or minus g of x, you can split this up into the limit of each piece plus or minus the limit as x goes to c of g of x, and this is L plus k, plus or minus k. The next property has to do with powers. So if I take the limit as x goes, products of f of x times g of x, I can split it up and it would end up being the same thing as L times k. The same thing with quotients, but there is one little caveat here, is that when you divide, the one thing you can't divide by is 0. So this would be L over k, provided k is not 0. And then the last one is a power rule. So it says the limit of f of x to the nth power, you can look at this as the limit of the inside, which would be L to the n. And so what we can do with these properties is now build up to more complicated limits. So let's look at the limit of a polynomial now. So let's find the limit as x goes to 2 of the polynomial 4x squared plus 3. So if I'm looking at the limit as x goes to 2 of 4x squared plus 3, the first thing I see is that I have addition here, and if I look back at my properties, my second rule tells me I can split this up into the limit of 4x squared plus the limit of 3. So over here on the right, I'll write which property we're using. We're using property 2. And then if I look here at this first one, I have a scalar, so I can pull that 4 out. I have a coefficient, x squared. And this is a limit of a constant, and we know that that limit is just going to be 3. So here I'm using property 1. And now I can just plug in 2 for x and get 19 for this limit. And so if you notice, if you go back to your original function here, if I just plugged in 2 in place of x, I would also get 19. So you might be wondering, is this always true? And the answer is yes, as long as your function is a polynomial. So I'll write the general rule here, is if p is a polynomial and c is a real number, then the limit as x goes to c of p of x will be P of C. So if you're computing a limit of a polynomial, you can just plug in your value into the polynomial and that will compute the limit for you.